Okay, hello dear friends. Let's do some mathematics. And doing mathematics, it's very important that you are calm and cool and not in a rush. When you are angry, your brain does not function. So let's copy this to No, I will write it down. 2x minus 3y equal to 9 and y equals 3. What is x? This one is very easy. You replace, plug in the y, the real value, into this equation. 2x minus 3 times 3, because y is 3 equal to 9. 2x equal 18, x equal 9, right? 3 times 3 is 9. 9 move to this side, it's 18. So the answer is 9. The second one is... Okay, I will not let you look at that paper. I just write it down, okay? I think it's better that I just write it down myself. We copy the problem. X minus y equal to negative 4 and x minus 2y equal to negative 6. Now we want to know x and y. So the first equation minus the second equation is x minus x is 0, negative y plus 2y equal negative 4 plus 6, y equal 2. Plug this one in. X minus 2 equal negative 4, x equal negative 2. So the answer is x equal negative 2 and y equal positive 2. The answer pair is negative 2, positive 2. Okay, let's do the third problem. Oh, this paper is too long. I will use this paper this way. Number 3, we will do number 3 later on because it's number 4 is not so relevant to this. If 5 over 8x equal negative 1 over 16, what is the value of x? Easy peasy lemon squeezy. I will use easy peasy lemon squeezy. I will use another color of pen to do this. 8 and 16 can be simplified. So 5x equal negative 2 over 1, x equal negative 1 over 10. So this is the answer. Number 5. Can you see it? Number 5. A to the power of 4 negative 6a to the power of 2 plus 10. So this one, they want to get us this answer, to choose the answer from this. The best thing we do it just honestly doing the transformation. Okay, so we can see here this one equal to a 4 minus a 6a to the power of 2 plus 9 minus 9. We plus 9, we minus 9. We do not change anything, right? But this we can change into a square minus 3 square plus 1. Now we see the answer. Look here on that paper. This one is just choosing one of these answers. So we found D is the answer. Because this is a SAT test, sometimes we just need to choose from this answer. It's not choosing a particular, it's not that you are figuring out an answer sometimes. Okay, in triangle ABC, okay, this one we need to read again also. In triangle ABC, angle C has the measure of 90 degrees if sine A equal to 0.6. What is the value of cosine B? You know that in a triangle, if one angle is 90 degrees, the other two angles are complementary. They complement to each other and make 90 degrees together. So the sine of one of the acute angle is the cosine of the other acute angle. So sine A equal to cosine B. We will draw a picture here so you can know. So we have triangle A, B, C, and C is 90 degrees. Sine A is 0.3. So we can say this one is 0.6. So this one is, let's do it this way. This one is 6. This one is 10. And cosine, sine A is 6 over 10. Cosine B is also the adjacent side over hypotenuse. So it is the same. Cosine B is sine A. Do I explain it clear? And number 7 is given. What is given here? The given is square root of m square minus 13 minus x equals 0, and m is smaller than 0, x equal to 6. Now we need to find the value of m. We can do this way. M square minus 13 equal x, and take out, and x is 6, we know. So m square minus 13 equals 6. M square minus 13 equals 36. So we square it on both sides. So m square equal 49. And we know m is smaller than 7. M is positive and negative 7. Since we know m is smaller than 7, so the positive one is out of the consideration. So m equal negative 7 is the solution to this problem. M is negative 7. Okay, now question number 8. Question number 8. Okay. If x to the power of b over x to the power of 3a equal to 16, and x to the power of negative 2 equal to 1 over 16, what is the value of b minus a? What is this? So we need to use our logarithm to really logarithm. We used to understand the notation of power. So the first equation we can write it x to the power of b minus a equal to 16. And the second one, because x to the power of 2 equal to 16, right? Because this one, negative 2 means the reciprocal of the certain number. Now, on the right side is the same number, so we can switch this equation. It's an identity, right? So x to the power of x, b minus a equal to x to the power of 2. So b minus a equal to 2. It's a pure number translation and algorithm translation. There is not much complicated. Once you know the rule, once you know the notation of mathematical equation, it is not that complicated. Number 9, we need to look at the paper, but we can do number 10 first. No, number 11. Number 11, the equation. Shall we do number? We will do it a bit later. Okay, at the end, we will do, I write it down. 9, 10, 3, we haven't do. We will do it together. And 5, I think we didn't. 5 we have done. Okay, so number 11. Let's do number 11. The equation. It's not comfortable. Let me change a little bit the location of the. Okay. The equation 12 x squared plus equal to 2 is true for all value of x equal to not equal to 3 divided by b. x3 divided by x 3 divided by b, it means this is 0, but x does not make it 0, so the upper part is an equation where b is a constant. What is the value of b? So when you see this kind of problem, it's kind of you cannot really see what is the problem. So oftentimes, before you do some mathematical computation and before you do the work, you cannot really see the problem and you cannot find the solution. So when you see this kind of problem, pick up your pen and start to do this. Start to work on it. So I copy it. 12x squared plus 6x minus 23 over bx minus 3 equal to negative 2 equal to negative 2x minus bx minus 3, and on top is 23. Okay, so what we need to do, we need to find the common denominator on both sides. Left side, we do not need to change anything. We only need to change the right side. The denominator is bx minus 3, and the numerator we need to time this, so negative 2bx squared plus 6x. This one is changed. Negative 2x we have changed. They have the same numerator. They can do the subtraction. Minus 23. Now when you see up to here, you can see what is the problem. This is the same, this is the same, this is the same, and only thing is not the same is 12x squared and 2b next. So negative 2b x squared. If this is identity, if this is an equation for all number except x not equal 3 over b, b 3 over b, then the upper part should be constantly the same. So all the rest is the same, only these two parts are not the same. So we should find a number to make these two parts the same. So 12 equal negative 2b. Once we solve this problem, we know b equal negative 6. So now we found when b is negative 6, this equation from left to the right is always good for any number. We will do individually. 13. Okay, let's take a look at the 13 and 14 and 15. Okay, let's take a look at 13 because it's time that we work on this a little bit more interesting problem. Okay, magnify a little bit. Y equal to a times x plus 3 times x minus 1. In the quadratic function above, a is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex m and n. Which of the following is equal to n? So this one is not a vertex form. When we see vertex, it is very likely that they want us to change into vertex form. So now we will go ahead to change it into vertex form. When we when we change it into vertex form, the problem will be much easier visible. So y, the problem is y equal to ax plus 3 x minus 1, and this is the equation we need to change into vertex form. Y equal ax plus 2x squared plus 2x minus 3, right? I did not change anything. I just did the multiplication, polynomial multiplication, equal ax squared plus 2x plus 1 minus 1 minus 3. Why do I do this? Because this one is x plus 1 squared. And I plus 1, I need to reduce 1. I have one positive 1, I have one negative 1. Then I did not change anything. If I cover this up, this equation, I did not change anything, right? If I put it up, you can also see I add up 1, I reduce 1, right? So a times x plus 1 square minus 4a. So what is the vertex? The vertex is negative 1 and 4a. So let's say this is a parabola, and here is the vertex m, n, and m should be negative 1, so I draw this picture wrong. I will need to do it again. X is negative 1 here, and y is 4a. Let's say this is 4a. So this is the parabola. This is the parabola what we are talking about. Negative 1 and 4a. Okay, now we take a look at problem 13. In the quadratic function above, a is a non-zero constant. The graph of the, when you see this is a is a non-zero constant, it's 0 degree, 1 degree, 2 degree function, and it's a parabola. The graph of the equation in the xy plane is a parabola with vertex m, n. Which of the following is equal to n? So when you see they ask a question about vertex, the first thing what we want to do is change this equation into vertex form. And once we changed it, we will be easily find out the problem. And right now, it seems not clear because we have not yet done anything. Now, we start to do it. Y equal y, no, 13 is the problem. Y equal a times x plus 3 times x minus 1, and we change into vertex form. First, we will need to do the multiplication. X squared plus 2x minus 3 ax squared plus 2x plus 1, so that we can make into a vertex form. We add 1, we need to subtract 1, subtract 3, so we didn't change anything. If I cover this one up, if I cover these two up, see, the equation did not change anything, right? I'm just copying the equation. If I show this one in, I add up 1 artificially, I need to artificially take away 1. So a times x plus 1 square minus this plus 1 is used, negative 4. Negative 4 with an a as a coefficient, so you need to minus 4a. Now we can see very clear what is the vertex. The vertex is negative 1 and negative 4a. So m is negative 1, n is negative 4a. I did not see, I'm sorry. So m is negative 1 and n is negative 4a. So we can see the answer to this problem is D. Okay, number 14. X equal to negative 2ax, x squared minus 2ax plus b equal to 0. In the equation above, a and b are constants. If this equation is solved for x, there are two solutions. What is the sum of these two solutions? So when you see a quadratic function and you need to know the root of the quadratic function, there is a formula. So the formula, now we work on the formula. ax 方加 bx 加 c 等于0 and x 等于2a 分之负 b 加减根号下 b 方减 4ac. This is the formula. So the root number 1 is plus and root number 2 is minus. So these are the two roots. And if we do the roots together, x1 plus x2 equal to positive, negative, we get rid of, and 2a, 2b. So it's negative b over a. Okay, now we need to make sure that this ab is not the ab in our problem. Now we copy the problem. The problem, this real problem, is x squared minus 2ax plus b equals 0. So this time we need to know the a from here. I will write it down in capital letter to make you distinguish a little bit. Okay, so a equal to 1, b equal to negative 2a, and this plus b does not even, we do not even need to use because there is no c. This is the capital C, and this one does not decide. This one in our root, in our formula, the b does not have an influence. So we will need to do the root. So x1 plus x2 equal to negative b. Negative b is negative 2a, and a is 1, so is 2a, positive 2a. Let's see, the answer is A. This is number 14. I think I made it correct. Number 14. I am always so eager to get the answer. So number 14 is A. Yes, we are right. Number 14 is A. Okay, number 15 is quite an interesting problem. I kind of forget it because the graph was not a clear picture. It is always quite complicated, and that was 40 years ago I learned it, so kind of forgot it. Anyway, which of the following can represent the graph in the xy plane of y equal to a times x minus b times x plus c squared when a, b, c are all positive constants? Okay. This problem, we do not need to do calculation. We do not need to change any form. So this one is a polynomial. Is the product of polynomial. So when x equal to certain number, y equal to 0, we can see how many chances y could be 0. When x is b, a positive, and when x is negative c, it becomes 0. So there are 2 points crossing when y is 0. So touch the x exit. There are 2 points at 2 values. 1, 2, 1, 2, 1, 2, 1, 2. They are all good. We cannot distinguish anything up to now. But we can distinguish something else. Okay. When x, but in the x plus c, it's squared. So it means the graph need to be bouncing at c. And plus c is here. So when c is negative, must be bouncing. At the positive part, it should not bounce. And here, b and c on the positive part, it bounces. So it get rid of. We will not consider b and c. And it's only in the negative part it starts to bounce. And also, we know a is a positive constant. When x is bigger than a certain number, it will go up, 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 up to the infinity. So at the end, it will go up. Makes sense? It will go up. And this one goes, when x becomes bigger and bigger and bigger, it goes down. This is not right. When x becomes bigger, the polynomial products of this a of the 3 numbers, let's say the 3 numbers must be going bigger and bigger and bigger. So this is the right one. Number 15. Do I explain it well? I'm sorry if I I have hard time to explain myself. I'm sorry to let you to torture you with all the all the confusions, the language confusion and the mathematics confusion. Okay, here we have a word problem at a restaurant. Each large order of fries has 350 more calories than one large soda. If 2 large orders of fries and 3 large sodas have a total of 1,500 calories, how many calories does one large order of fries have? So, to solve this problem, we can use some acronym for the problem. Okay, you need to see the problem, right? In the restaurant, there are large order of fries. So we have large order of fries. We use it. The calorie of fries has 350 more than soda. The calorie of soda. Okay, so we have first equation out, and the second equation is 2 large of fries, 2 large fries, and 3 large sodas together makes 1,500 calories. Once we figure out this equation, adding the number will become much easier. Will become just a matter of computation, right? 2f, we can substitute 2f by f with this f. 2f is 700 plus 2s plus 3s equal to 1,500. So 5s equal to 800, s equal to 160. So what do we figure out? We figure out the calorie for soda. And what they want to know, what they are asking us, is the large order of soda, large order of fries. So large order of fries is f equals 350 plus soda plus 100 plus 160 equal to 510. So we figure it out. Okay, another problem, if 17 is a equal to 4 times the square root of 2 and 2a equal to square root of 2b. What is the value of b? So we just plug in a. 2a is 8 square root of 2 equal to square root of 2b. Okay, we square on both sides, so 62 times the square root of 62, 4 times 2 equal to 2 times b, right? So b equal to 64, right? Easy peasy lemon squeezy. And in the figure above, a circle is inscribed in a square that is inscribed in a large circle. If the area of the larger circle is 16.5 square unit, what is the area of the smaller circle? So what we will do, we will draw a circle, a large circle. I'm not so good at drawing a large circle. In the large circle there is a square. It's right at the edge of it, and in the square there is a smaller circle right at the edge. So we know the large square area, the radius of large. So large is the area of large, A large, equal to pi r square, equal 16.5. And the area of the small one is A equal pi times r square. And we do not know. But we know the relationship. This one equal to this one. Why? Because this is a square. This is a square. This one is a square. In the square, the whole line, the radius, the small radius, and is the same length here. And the big radius is here. So it's 90 degrees, and with these two angles same, so it's 45 degrees. And this is square root 2 of r. Okay? So the small area is A, small area is pi times square root, I write it this way, pi times square equal pi times r 分之一 r square. So we see the difference. It's only half. The area is only half of the big one. So A equal, we know pi r 分之一 pi r square, and this one is 16.5. r 分之一乘以 r 分之一乘以 16.5, so 8.25. Okay.